Okay, it's recording, okay? So it'll be online or whatever you want to say it, what you're saying. So, and again, this is only going to be used for, the recording is only used for people that can't make it right now. There's some significant things going on that are causing people to miss. So I appreciate the vast majority of you are here. You can go back and look at this later yourself too. It takes a little while for the YouTube to process the recording, and I've got to manipulate things a little bit in order to get it done. So it will be a matter of a little later this afternoon before it'll be up, but you can look at it also yourself. All right. One of the main things I want to talk about is I went and looked in sapling, and I noticed, and some of you may have confidence in yourself or something, and you haven't been necessarily doing the chapter 1 problems. I've noticed that several of you, probably 8 or 9 of you, haven't done any of the sapling problems from chapter 1. And if you're confident with it, that's wonderful. But if you're not, that's not using the tool. Okay. The goal is get this stuff down and nail it, and not wait until exam day to do the homework problems. Try to get caught up over the weekend. Try to get the stuff done if you haven't done them up to this point. For tomorrow, 1.5 and 2.1 and 2.2 will be ideal problems to work through. Okay, so I encourage you to do that, and do take a shot at the problems. Again, you've got chapter 1 credit, but believe me, that some of you that didn't score real well on the first quiz don't show any problems done, and that consistency doesn't sound good. So I really encourage you to use sapling, do the problems, get it down, and we'll go from there. One of the things I want to point to is one of the first things is that 1.5, if you recall, I'm going to ask at least one question from 1.5. And that's got to do on the quiz tomorrow. And that's got to do with the limit infinity, the limits in that direction. So make sure you take a look at the questions. Some of them are very straightforward, some a little more algebraic manipulation needed. And that's true in 2.1 and 2.2 also, okay? There's some that require some algebraic manipulation, and I'm going to encourage you. I left them in there intentionally so that you do have to make sure you true up your math and go in that direction. So what I want to do, though, is I want to go through and talk about, I'm going to look at my iPad just for a second and show you the formula from 2.1 and the key formula, the limit formula from 2.2. Okay? Let me just see if the screen comes up here, and it's not exactly popping up again like last time. Okay, so let me do that again. So I wonder if recording's doing anything with that. Let's go here. I'm going to go to my iPad. All right, here we go. Very, very good. Okay, these are what the problems are on that sheet of paper I gave. That I said the breakout problem, practice problems, breakout room practice problem. And this is section 2.1. This is a function. I'm pointing to this top function, that f prime at c. And what it says, the initial definition given in the text is, this is the slope of the tangent line to this function at the particular value of x equals c. Okay? It's the slope of the tangent line. All right, well, by the end of that section, 2.1, it changes the definition a little bit. They use the word derivative. This is the derivative of the function f of x at a particular point c. And that's finding the slope, and it holds true. It's finding the slope of the tangent line at that point, c. And the idea, the x value c. And the idea is, so if the terminology is saying, what is the slope at this point on the graph, it's talking about the tangent line. So it's mixing words together. Later it says derivative, and then later, section 2.2, we go back to this limit definition of derivative I had talked about before, that talks about instead of x going to c here, x approaching c, and then in other words, this distance becoming 0, this is taking it literally, the h is going to 0. And you just add a little bit to the h. And that's the original function we had talked about at the beginning of the semester. The word derivative is being used for this. At the end of section 2.1, the word derivative is being used for this, at a point. Derivative at a point, okay? At x equals 1 is what I want to do in just a second here. And I'll do that problem completely when we get back from the breakout rooms, okay? So
Dr. Wenta,
go ahead, yeah.
Is 2 f prime of x, so that's finding the derivative of the function then, right? Not at a single point, but of the function itself.
This down here.
Is that what you're getting at? Yeah.
Yes. So
okay.
this is also the derivative of the function at a point.
At a certain point. Okay.
And you're right. This is the derivative of the function. And sometimes, you guys, so for instance, if we have a line, all right, the derivative is the slope. For a line, the derivative is always the same. It's whatever the slope is, all right? If you've got y equals 2x plus 1, m is 2. That means the slope is 2 for the entire graph, all right? Now, if we've got a function that's a parabola, look at this one on the screen here. This is a parabola. The slope changes throughout the function. So the derivative is going to have an x in it. The derivative is going to change wherever you are on the graph, depending on where the x is. You know, the slope is going to go from the left side being downhill on the parabola to the right side being uphill, and it's 0 at the middle, you know? So there's going to be a variable left behind, but if you've got a line, the answer is just going to be a number, because the derivative, the slope, is a constant. It's whatever the slope is of the line. That's it for the entire graph. Okay? So we'll go through this. I want to go through these specific problems when we get back. Okay? I want to split you guys into breakout rooms right now. So I've got to go back to stop share for a second. And what's going to happen, looks like there's 30 of you here. That's great. Part of the situation is I'm going to put you in breakout rooms. It's going to be automatically split you into groups, okay? So if you want to start talking about the problems that I was looking at or questions about it, you can feel free to do it. It's x squared plus 4. What's the derivative at x equals 1? What is the slope at x equals 1 is what I was asking. But here's, I'm going to split you into breakout rooms, and I'm going to come around to each group and just say, hey, okay? So and next week, we're going to do this. You're going to spend time with the people. You may want to introduce yourself. Just say what your first name is or whatever, and just say, hey, and go from there. What I want to do right now, though, is go back through that worksheet that you can go back and look at it yourself. Try the problems yourself. Make sure you do them if you haven't seen it yet. It's back on week 3, and it's called Breakout Room Practice Problems, okay? The first question comes from 2.1. I'm going to go to my iPad right now and do that. And hopefully it'll be very direct.
Oh my God.
There we go. Got it. Okay, good, good. All right. Like I said, early in section 2.1, this was described as the slope of the tangent line at x equals c. Okay? So, and at the end of the section, they come off and call it the derivative. And at a specific point, x equals c. That's what this is doing. So I'm going to give this to you on a quiz and ask you to use it. All right? On the quiz, that's going to be one of the questions. So the idea is, I'm going to say, so find the slope of the tangent line, and then we'll finish it off and write the equation of it too. Write the equation of the tangent line. That was stuff we did at the beginning of the semester that we're going to go back to. I'm going to ask you to do that. So right now, let's go through this. Number 1, the function is x squared plus 4. Notice that it's a parabola. So that means when you take the derivative, the slope is going to be different at different places. So that means there's going to be an x in your answer, all right? But we're finding it exactly at x equals 1. C equals 1. So this formula is, we're going to use this and do it right now. So watch this. I'm going to use the formula, all right? So this is, notice that I'm saying this is the formula we're using. C is equal to 1. Therefore, 1 needs to go in the limit, in f of c, and down in the denominator, c again. So f prime of 1 is equal to, the limit is an important part of the correct answer, you guys. Plug in 1 there for the limit. Then we've got on top f of x minus f of 1 over x minus 1. All right? So notice right now, limit as x goes to 1. You plug that in the denominator is 0, illegal, right? Can't happen. Well, in the process of doing this problem, x minus 1 is going to be a factor of the numerator. And x minus 1s are going to cancel. And you'll be able to plug the 1 into the function. So let's do this. So what is f of x? You write f of x just like it's written. So this is equal to the limit as x goes to 1 again of f of x is x squared plus 4. You can put that in parentheses if you want to, but they're both positive, so that's not, it doesn't matter. Then you've got minus f of 1. Well, what's f of 1? Well, you could do that off to the side if you want to, and then plug the number in. Let's go ahead and plug it in right here. F of 1 is equal to, I plug 1 into the function. That is 1 squared plus 4. All right? And that is over x minus 1. Denominator is still the issue. The limit, you can't plug 1 in because the denominator is 0. Let's move on. Next, lim is still with us. X goes to 1. What do we have up there? X squared plus 4. 1 plus 4 is 5. So we've got minus 5. Do you see what that's going to turn into? Do you see a difference of 2 squares coming? Are you looking at that? So this is the limit as x goes to 1 of x squared minus 1 over x minus 1. So you've got the difference of 2 squares. Factors into what? X plus 1, x minus 1. The x minus 1 is going to go away. Okay? So let's do that. That's equal to the limit as x goes to 1 of x plus 1, x minus 1 over x minus 1. I put parentheses around the bottom. You didn't have to, but I'm getting ready to just show that it's a factor. Same as the top. Cancel, cancel. So now I've got the limit as x goes to 1 of x plus 1. Now the denominator's gone. It's not a problem. So I can stick 1 in for x. You wait until then, until the denominator goes away. Now plug in 1. So that gives me, and when I plug in 1, LIM goes away. I'm plugging it in. Therefore, I'm finding the limit. So the limit as x goes to 1 is 1 plus 1, which is 2. Notice the lim is gone. No lim. All right? No limit symbol. So the answer is 2. So that means f prime at 1, notice I got equal signs all the way down. Equals, 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 equals. If you guys don't do that on the test, I'm going to start taking off, okay? Get practice on it on the quiz. So f prime of 1 equals 2, which is the slope, okay? Now, remember this. One advantage of plugging in the 1 somewhere, f of 1, we got 1 squared plus 4, that's equal to 5. Well, the situation is, you're going to need, you've got the slope at x equals 1, but you need the point also. Well, the y coordinate is 5. So the point is 1, 5. All right? So now, I'm going to use y equals mx plus b for this one. If I ask you to write the equation of a line, you can either use slope-intercept or point-slope. And so y, 5, equals m, we calculated as 2, x is 1, y is 5, right? All right, plus b. So that means b, so if I subtract 2 from each side, I get b equals 3. Therefore, the equation of the tangent line at x equals 1 is y equals, the slope is 2, and b is 3. Okay? Now, really quickly, I want to remind you, get in the habit of doing this. Put this on your calculator and verify. Let's go to Desmos. I'm going to put the graph of the parabola and the equation of the line on the same graph, and let's see how it turns out. It should be, it touches at one point. It touches at the 0.15. Okay?
I have a question.
Yeah.
So are we always going to have to show like our work for finding the, like, are we always going to have to show that, or can like eventually can we just use like the rules for derivatives to find it?
On
Like,
this quiz and on this test, I'm going to ask you to use this function.
yeah, because like, and then
that means you got to use the, that means you got to do that. There's another way to do it shorter, I know.
yeah,
And we're going there. But right now, you got to step back and do it this way, okay? I'm going to ask you
Okay.
on the quiz, you got to do it this way. If you've already gone through and you got a handle on being able to do it another way, I want you to demonstrate to me you can do it this way, all right?
okay.
That's good question. Okay, so let's go to the graph. I'm going to go to Desmos real quick. Okay, let's go to, okay, here we go. Here's the graph, y equals x squared plus 4, okay? Y equals x squared plus 4. Notice it's the parabola y equals x squared moved up 4 spaces. Start getting a picture of that in your head. And now we've got the equation of the line y equals 2x plus 3. Graph it. Got it. Look where it crosses.
Dr. Winta, you're still on your iPad.
Oh, that's not good. Thank you for speaking up. Okay, I'm going to back up here. And let me back out. Thank you for saying that. Thank you. New share. I'm going to go to here. Okay, so what I had originally was, here's the function x squared plus 4. It's y equals x squared moved up, over 1 up 1, over 2 up 4, up, and the whole thing moved up 4 places. That's y equals x squared plus 4. Now, draw the line y equals 2x plus 3. If it doesn't touch at 1, 4, something's wrong, okay? So notice where it touches. You can zoom in there and verify it's at 1, 5. That's where that thing touches, okay? That verifies your answer's right. If it doesn't touch there, something's wrong. You did something wrong, okay? So what I want to do is I want to go back and let's do the second question now. Any questions on that? Every time you do it, you guys, I encourage you to get in the habit of doing that. Make sure your answer's right, okay? If you're confident, then maybe you don't need it. But the idea is to, I'm going to go back to my iPad. Yeah, the idea is to make sure you check your work. Okay, so now look at the second question. The second question says, here's the first question. Now, what somebody had asked a little bit ago was, notice that this derivative is of the function. The answer is not going to be a point. It's not going to be the slope. This is the derivative of the function at any point. That parabola, wherever you are, the slope's different. Well, there's an equation for that to figure out what that function is. And that's what the derivative is. So this f prime of x, using what we did at the beginning of the semester, gives us the slope at any value of x. You plug in x and you've got the slope. It's kind of a trip that the math works this way. It's pretty cool. Let's do this kind of quickly, okay? So I'm going to do f prime of x then is equal to the limit as h goes to 0, f of x plus h. Notice what that means. F of x plus h means I got to take f of x. I got to take f of x and plug in x plus h for it. So what I'm going to do is I'm going to remind you, like I did earlier in the semester, our function is something squared plus 4. And wherever that something is, x plus h goes there now. And that is squared. Okay? That is f of x plus h. Minus f of x. Our original function is just x squared plus 4. Okay? And that is over h. And now you guys, the h going to 0, the limit is h going to 0, the h is there. Remember that h is going to disappear. So we end up with the limit as h goes to 0. I could have put a smiley face there. That would have saved the moment. Remember, this now is x squared plus 2hx plus h squared plus 4 minus, now I'm going to distribute that minus sign, minus x squared minus 4 over h. Notice always, you guys, both of these terms should go away. If they don't, something's wrong. Okay? And you end up with the limit as h goes to 0 of 2hx plus h squared over h. H is common on top. Factor it out. I get 2x plus h over h. Now the h's cancel. And now I'm going to save a step, and you can do this yourself too. Officially, one more step. I'm going to do one you don't have to do, but now we've got this. That's what we're down to, okay? You could have done that when you're taking a test or something like that, time saver. You could plug that in right here and do it, okay? But now h goes to 0, therefore I'm going to plug in 0. Now lim goes away because I'm plugging in 0. I got 2x plus 0. The answer is 2x. Okay, notice this, you guys. This is the slope at any point on the parabola. If you're at 0, you plug in 0. The slope is 0 at the bottom. You plug in 1, like we did at our first part of the question here. Notice what the slope we got in that first part. M equaled 2. Plug in 1, you got 2. So the slope is going to change wherever you are, whatever x value you're plugging in.